Welcome back. Today we're going to look at complex numbers. Let's first consider some of these definitions. So when we had factors that were x squared plus 1, we were not able to identify what x equals. So mathematicians created the imaginary number, which is the square root of -1. So we define I, the imaginary unit, as the square root of -1, and I squared as -1. When we have the imaginary units, they are defined in the complex number system. The complex number system comprises of two parts. A is the real part of the complex number, and B, as long as B doesn't equal 0, is the imaginary part. If you do have a number in the form bi, where a equals 0 and b does not equal 0, this is called a pure imaginary number. With imaginary numbers, we can complete operations just like we do with regular numbers. If we have an equality, such as a plus bi equals c plus di, well, we need to make sure that the real part equals the real part of the other complex number, and the imaginary part equals the imaginary part of the other complex number. We can add and subtract complex numbers. We have to make sure that we add the real parts, a plus c, and then add the imaginary parts together. We can also do that with the difference. We can subtract them or add them as long as we're sticking with the real parts and the imaginary parts. We can also multiply them by a negative to find the additive inverse. Now the key idea, whenever we have the square root of a negative number, we're going to take that I out whenever we're trying to simplify numbers. So if we're going to simplify the square root of -50, well, we know that can break down into -1, 25, and 2. So that -1 is going to come out as an I. The 25, well, that's a square root of 25 is just 5. But the 2 will have to stay inside the radical. So this will equal 5 square root of 2 I. Just make sure you don't include the I under the radical. It needs to be outside the radical. Now let's simplify square root of -25 times the square root of -4. It's very tempting to multiply them right away, but if you notice, you would get 100 and you wouldn't have the I anymore. So make sure you always take that I out. So here we'll have 5i, and the square root of -4 is going to be 2i. So now we get 10i squared, and we know that I squared equals -1, so we'll get -10. When we have a number in this form, we want to make sure we write this in standard form. So we have square root of 8. Well, again, that can break apart. The square root of 4 is 2. A root 2 will stay inside, and an I will come out. But remember, we need to write the real part first. So in standard form, it'll be 2 plus 2 root 2 I. Now looking over here, for this one, we need to make sure that we separate this into two different numbers. So we'll divide the 5 by 10 and divide the 4 by 10. We can reduce these fractions, so we get 1/2 minus 2/5 I. When we add or subtract complex numbers, we need to make sure that we combine the real parts and then the imaginary parts. First, I'll distribute the negatives. So it's -7 plus 3I minus 10 plus 5I. So we'll get -17 plus 8I. When we multiply, we're going to FOIL because it is almost like a binomial. So I'll have 4 times 3, which is 12, 4 times 5I, which is 20I, -3I, and then -5I squared. Remember that 5I squared, well, the I squared changes into -1. So it'll be 12, and this will turn into +5, and then I'll have the 20I minus 3I. So in standard form, we'll get 17 plus 17I. Now it's time to sound like a pirate, because we're going to cover the powers of I. Okay, so remember we said I is the square root of -1. And we said that I squared is going to equal -1. So what's going to be I cubed? Well, we can break down I cubed into I times I squared. And we know that I squared is -1, so this will equal -I. I to the 4th, well, we can split that apart into I squared times I squared, which is -1 times -1. So that'll equal 1. So if you notice, the powers of I repeat every 4. I is just I, right? I squared is -1. I cubed is -I. And I to the 4th is 1. So let's look at I to the 13th. Well, we can split that into I to the 12th times I. And we know I to the 12th is really I to the 4th cubed. And we can tell that I to the 4th equals 1. So 1 cubed would just be 1. So this must equal I. Now let's look at 403. Well, I'm going to break it apart into I to the 400th times I cubed. So I to the 400th, well, that's 4 to the 100th. And we know that I cubed is -I. So I'm going to put this as -I. So we'll just have 1 times -I or -I. Just know that this function is a modulus function and will keep repeating every 4th. Now let's look at complex conjugates. A plus bi and a minus bi are complex conjugates. So if we want to rationalize this fraction, we can multiply the numerator and denominator by the conjugate of the denominator. So it's -6 plus 2i. So we'll multiply the top and the bottom of this fraction with -6 plus 2i. So in the numerator, we're going to have to FOIL. So we get negative 30 plus 10i minus 6i plus 2i squared. In the bottom, in the denominator, we'll get 36 minus 4i squared. So we can tell in the top, this 2i squared is going to become negative 2. And this 4i squared becomes negative 4. So let me just write it out. So we have negative 30 plus 4i. This will be minus 2 because that I squared is a negative 1. And then on the bottom, we'll have 36 minus a negative 4, so it ends up being plus 4. Let's simplify that a little bit more. So we get negative 32 plus 4i in the numerator over 40. But remember, we need to write that in standard form. So that's going to be negative 32 over 40 plus 4 over 40i. And these fractions can reduce. 8 goes into 32 and 40, so it's going to be negative 4/5. And this will be 1/10 I.